Hey everyone, this will be the first video in a series to go over 3-axis programming in RhinoCAM. We've covered a lot of the bases in the 2-axis training, so hopefully some of this will go a little quicker. I just wanted to start by going over once again just the file setup, the layer organization, and talk just about some of the principles with 3-axis programming and how it's different from 2-axis programming. I also wanted to quickly go over updating the post processor and the tool library once again, just because now some of you may be using this on your own computers, and where we thought you might have the libraries pre-installed on the virtual, the render computers, you may need to install them yourselves. So I'll just go over that quickly to start. For the tool libraries, once again, this icon here, if you click that, mine are already loaded, but what you do is go to Load Tool Library here. It's going to bring you to some location. It doesn't really matter where they're stored. If you have them on your personal computer, I'm going to navigate to the desktop. So these files, I have everything in the ARC 1502 folder, and I have tool libraries here, so I could load my tool libraries, either the drill or the regular tool library. If I click open, it's going to add all those tools in again, but that's how you load the tool libraries. I'm just going to cancel for now and close this out. What's a little more complicated is the post processor. The default CNC Motion post processor in RhinoCAM includes some other code that we don't need, so we want to use our CNC Motion AAP post processor. So you can find where these files are stored right here. It shows you the address, but I'm going to just quickly navigate to there to show you how to find that. So if I'm going to just open up my 1502 folder here, and in here, so we have the correct post processor. So it's the CNC Motion AAP. And what I would do is, I may already have it open here, but I'll just go back. So I would want to navigate to the C drive. Make sure up in View that hidden folders are shown, and that will show you this program data folder. You can open that there, and then go to MechSoft, RhinoCAM 2020 for Rhino 6, Posts, Mill, and that's where all our post processors are located. And if I go down, you can see here I have my CNC Motion AAP already in there. But essentially what I could do is just copy, right-click, copy, and then right-click and paste my post processor in this folder. And at that point, it would be available as an option in this post processor menu here. Okay. Looking at our file setup for 3-axis programming, you can see that it's pretty similar to our 2-axis program file. I have a new file here that I've set up. Once again, I have a layer for the CNC bed, so this is just a rectangle that represents the 4 by 8 foot dimensions of the bed. In this series, we're assuming that we're cutting a sheet of 2-inch thick extruded polystyrene foam. And so for my layer, for my material layer, I have the name foam here, and I've made a box that represents a 2 foot by 4 foot by 2-inch thick sheet of that foam. The extruded polystyrene you can get usually, you can also get in 4 by 8 sheets. You can get it in 2 foot by 8 foot sheets and 2 foot by 4 foot sheets. If I hide my foam layer, you can see that I have a variety of part geometries laid out. So these are 3-dimensional models, objects in Rhino that I want to cut or carve with the CNC. And then I also have a part regions layer, which if I select those objects, you can see that those are all curves. So the basic premise with 3-axis cutting is that essentially what we've got defined here, we want to say, here's our material, this is what the material that we're going to cut. And then we have our parts. Here are our 3-dimensional part objects or shapes that we want to cut out of that material. And then the region layer is going to function as curves that say this is where we're cutting within this material, or this is where our parts are located within the material. So you'll notice in here that the parts that I've laid out, I've tried to represent a variety of geometric conditions within these parts. And these are different geometries that we encounter through some of the different files that we see in the lab. And there can be different approaches to carving out these geometries. We may choose certain operations depending on the shapes of our geometry. So that's something that I'll be going over in the series. The basic approach to 3-axis programming is to first start by carving away all the material that we don't need. So we're going to tell RhinoCAM what our stock material is. We're going to tell it where our parts are located, and then it's going to calculate what material needs to be removed based on that information. And then what we would do with all that material that we don't need carved away is we will come back through and do what's called a finishing pass to actually cut to the surfaces that are represented here. So if we look at the different machining operations and the 3-axis menu, once again you can see that there are a lot of operations available to us. And once again, I want to point out that 90% of the time, we're just going to be using these operations over here. So these are what I'll be covering in this series of videos. As I mentioned, to start, we want to carve away all that material that we don't need. And so we're going to be doing the horizontal roughing operation to do that. And then we would follow through with a finishing pass. And so typically we're going to use either a parallel finishing, a horizontal finishing, or a projection pocketing. So I'll go through each of those and look at how they might be applied to different types of geometry. I'll also look at the pencil tracing. That can be a pretty helpful tool to clean up some of the edges of our geometry. But most of the other operations in here rarely get used, if we even use them at all. So I just wanted to point that out. So that's the basic premise. I'm going to stop there, and I'll pick up in the next video just to start with our horizontal roughing operation.